So here's a basic, straightforward Lorentz transformation example. Let's say that I am walking and I walk 1 kilometer in 10 minutes. Getting used to talking about the concept of an event. Let's say that at t equals 0, I start walking, and at t equals 10 minutes, I have walked 1 kilometer. So there's two events, starting walking, and after 10 minutes, I've walked 1 kilometer. Right? So those are two events that we can write in what frame of reference, right? What frame of reference? So this is me walking 10 kilometers, t equals 0, t equals 10 minutes. So what frame of reference? That's not my frame of reference, right? In my frame of reference, how far have I walked? This is a really important point. It's going to mess you up later. According to my frame of reference, right, in my frame of reference, I carry my frame of reference with me. So if I start at x equals 0 in my frame, and I'm still carrying my frame with me, where am I in my frame? I'm still at x equals 0, right? So in my frame of reference, I haven't moved at all relative to a frame of reference that I carry with me. So this is what frame of reference? This is the lab frame or the road's frame, right? So, or the Earth's frame. So this frame is the Earth's frame, not my frame. Okay, I don't care about my frame of reference. It is just an object moving in the Earth's frame of reference. Okay, that's besides the point. We didn't actually have to recognize that to do this problem, but we will have to recognize that to do other problems. So what does an alien say who is flying by at 0.6c? I don't know because I don't speak alien. No, that isn't what I meant. What I meant is if according to the Earth's frame of reference, delta x is 1 kilometer and delta t is 10 minutes, then what does the alien think is delta x and delta t according to them? Whoops, not delta t, double prime, delta t, according to the alien. So a couple of assumptions we need to make. First of all, the alien is certainly the moving frame of reference. The alien is moving at speed v, and we want to know what is the alien measuring from his or her frame of reference or their frame of reference. And because why would we put a gender on an alien? And the other assumption, which I'm going to leave off all the time, is the assumption is that at t equals 0, we're at the same origin. So we don't have to worry about different origins. That just makes our lives easier in terms of these calculations. So at t equals 0, we're in the same place. T equals 10 minutes. Where is the alien at t equals 10 minutes? So I am 10 kilometers along the road. Where's the alien in 10 minutes? Just FYI, right? The alien is way, way out here because the alien is traveling at 0.6c. So in 10 minutes, the alien is far, far away. So just as so what is what is my position relative to the alien, delta x prime, gonna be? I'm gonna be behind the alien by a long way. So delta x prime should be a large negative number, right? Because the alien is way in front of me. So right now, at t equals 0, I and the alien are in the same place. We're both at x equals 0. X and x prime equals 0 at t equals 0. T equals 0, we're at x and x prime equals 0. At t equals 10 minutes, the alien is way out here, and I am here. And so I am at some very large negative distance relative to the alien at 10 minutes. That's just something you got to recognize. You shouldn't be surprised by the answer. So we can just go ahead. This is a straightforward plug-in, actually. Delta x prime is equal to gamma delta x minus v delta t, and delta t prime is equal to gamma delta t minus v over c squared delta x. And we just plug in, but we got to identify these variables, right? Delta x is 1 kilometer, delta t is 10 minutes, v is 0.6c, and then the only thing left is gamma. What is gamma? Gamma is the square root of 1 minus v squared over c squared, so that we got to plug in and figure out what gamma is. Okay, so gamma is 1 over the square root of 1 minus 0.6c over c squared, right? V squared over c squared. And so gamma is, notice that we often write velocities in terms of c so that these c's cancel. So gamma is just 1 over the square root of 1 minus 0.6 squared, which is 1.25. Notice also that gamma should always be between 1 and infinity. So it better always be bigger than 1. If you find gamma is less than 1, what you've probably done is by accident inverted it. So therefore, delta x prime is equal to gamma 1.25. Oh, what are the units of gamma? Gamma is a ratio of two velocities. It's unitless, right? Well, it's a ratio of two velocities and then related to 1, but it's unitless. Okay, times delta x. Delta x is 10 kilometers minus v, which is 0.6 c, times delta t, which is 10 minutes. So now we got to pay attention to units. And so if we change this all to seconds and meters, right? So we got 10 kilometers is 10,000 meters, and 10 minutes is 600 seconds. So plugging in for delta x prime, I just plug those numbers in. You get minus 1.35 times 10 to the 11th meters. You say, wait, that's an unimaginably high number. Well, the alien spacecraft is going at unimaginably high speed, right? It's going close to the speed of light. So in 10 minutes. 10 minutes is enough time for more than enough time for light to get from here to the sun, right? So the alien can go as far as the sun almost in 10 minutes, right? Okay, and delta t prime is gamma 1.25 times delta t. Let's just write it in seconds, 600 seconds, minus v 0.6 c over c squared, v over c squared, times delta x, which is 10 to the 4th meters. Sorry, I keep making these little tiny mistakes. I can't walk 10 kilometers in 10 minutes. I can walk 1 kilometer in 10 minutes, which is what I had said originally, 1 kilometer in 10 minutes, but then I changed it to 10 kilometers. It doesn't matter. For the sake of the calculation, it doesn't matter. But let's go ahead and make this 1 kilometer and go ahead and plug in here 1 kilometer. 1,000 meters, 10 to the 3rd meters. And believe it or not, doesn't change a thing. It doesn't change a thing because this number is so small compared to this number. It doesn't change anything. And we still get minus 1.35 times 10 to 11 meters. Okay. So back to the delta t prime. I'm just going to multiply this out. 1.25 times 600 seconds minus 0.6 times 10 to the 3rd over 3 times 10 to the 8. I just canceled the c on top with the c on the bottom, and that's how I got this. And so you'll notice that this is extremely small compared to this right now. But the answer is not 600 seconds. The answer is 600 seconds times 1.25. We've got that factor. That was called the Lorentz factor, right? This factor, the Lorentz factor. I know we didn't call it that before. But that's multiplied by time. So the alien doesn't say it takes me 600 seconds. I say it takes me 600 seconds to walk a kilometer. The alien says it takes me 750 seconds to walk a kilometer. Why? Well, the answer is because we're in 2 different moving reference frames. In 2 different moving reference frames, you have to measure 2 different times. That is a conclusion that comes from Einstein's second postulate, that you have to measure 2 different times. Now, who measures the shorter time and who measures the longer time? We will see soon enough that the person who measures the shorter time, the person who measures you always hear moving clocks run slow. But actually, you got to be really careful about that because we both have moving clocks. We're both moving. And so you might say, well, isn't the alien moving faster? So no, it's more complicated than that. But it's the fact that I am present. This is important. It comes up later. I am present at the first event, leaving my house, let's say. I am present at the second event, completing a 1 kilometer walk. But the fact that I am present at both of those events means that I measure the shortest time, the shortest possible time between the 2 events. That's not obvious here. We're going to prove that later. But I'm just pointing out right now that I measured 600 seconds between the events. The alien measures 750 seconds between the events. This is real time. This is what the alien will actually measure if the alien has the exact same watch as me. It won't be apparent. It won't be, it's real. That's how much time has gone by. The alien has aged more than I have while I'm walking that 1 kilometer. I've aged 600 seconds. The alien has aged 750 seconds. It's biological aging. And I measure the shortest time. Again, this is where we're going to learn later, because I am present at both events. That's the person who measures the shortest time. The person who's watching from afar, who's not present at both events, is going to measure a longer time than the person present at both events. That's just a result that comes later on.